projects. In this video, we are going to explain about project titled Deep Learning for Apple Disease Classification and Identification. The project's introduction emphasized the significance of roots in all global cultures and of the disease affecting them. The occurrence of the disease and this crop causes the agriculture loss and economic setbacks. An illustration of this is provided by the financial impact of leaf roll disease on the grape production. Furthermore, if a tree is infected, it leads to the spread of infected fruits, which in turn affects the stem, shoot, and even smaller branches. The objective of this project is to suggest a classification model based on the deep learning that can differentiate between the diseased and healthy fruits. The model employs an convolutional neural network for the purpose of multi-classification and prediction. The model's effectiveness is accessed using the accuracy as a performance metric, and the results are examined in the terms of their potential for future development. The proposed model offers an automated system for identifying the disease in apple leaves with the potential to expand its application to other fruits and vegetables in the future. The basic requirements needed to build this project are hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement, Python IDE with version of 3.7. And these are the modules we implemented to build this project. And the first module is upload the apple disease dataset. This module facilitates the uploading the apple disease dataset into the application. The dataset contains the various images of apple plants affected by different diseases. And the second module is pre-process the dataset. This module involves pre-processing the dataset before training the model. Data augmentation techniques are applied to augment the dataset by creating the variations of the existing images, which help in improving the model's ability to generalize. Additionally, the image pixel values are normalized to a range between 0 and 1 by dividing each pixel value by 255. This normalization step ensures that all image pixel values fall within the desired range, and as the original image have the pixel value ranging from 0 to 255. Once the dataset is pre-processed, it is ready for training. And the third module is train the CNN model. And this module is responsible for training the convolutional neural network using the pre-processed dataset. The CNN model learns from the features present in the dataset and is trained to classify the images into different disease categories. After training, the accuracy of the model is evaluated using the test images, which provides an indication of its performance. The trained CNN model can then be utilized to classify the disease in any text image. And the fourth module is accuracy and the loss graph. This module generates a that depicts the accuracy and loss of the CNN model during the training process. The CNN model is trained over a specific number of iterations or epochs, and at each epoch, the accuracy and loss metrics are recorded. Plotting these metrics over the course of training help in visualizing the progress and performance of the model. And the final module is upload the test image and predict the disease. This module allows the users to upload a test image, which is then processed by the CNN model. The model applies its learned knowledge to classify the disease present in the test image, providing the predictions and identifying the specific disease affecting the apple and the image. The execution of this project. To execute the project, first we need to open the code folder, that is, and here it consisting of different files. Here the dataset folder consisting of train folder consisting of 4 different types of folders. The first one is apple mosaic. Here it consisting of different leaf images which represents the apple mosaic disease. And in the same way for healthy means that this leaf is healthy in state. And in the same way for powdery mildew and also for scab. And this model folder consisting of H5 files which contain the deep learning algorithm information. These .h5 files can be loaded into the project code during the runtime to utilize the trained model for the various tasks such as making predictions on new data or performing the specific operations. And the test images folder, here it consisting of different images which is used for the testing the data. And this apple disease is an Python file which is the main code file, and the run.bat file. Instead of executing the program in command line interface, we created a Windows bat file to execute this project. Now to run the project, double click on the run.bat file for the execution of the project. This is the graphical user interface of this project, which is for interacting with the program. And now click on the upload apple disease dataset button. This is used to upload the dataset. For going to import the dataset, we are selecting the dataset folder and click on select folder button. Here we can see that the dataset is loaded, and click on pre-process dataset button. Here it is used to normalize and resize all the images within the dataset. Here it can show the total images found in the dataset is of 208, and the dataset contains of images of 4 different diseases, and here of apple mosaic, healthy, powdery, mildew and scab. Here the dataset is ready, and now click on Train CNN Model button to train the CNN with the above dataset features. Here this dataset is trained with CNN, and the trained model use the accuracy of 99.03, and here 0 represents of apple mosaic, 1 represents of healthy, 2 represents of powdery mildew, 3 represents of scab, of precision, recall, FN score and support, and click on accuracy and loss graph. In this screen, the graph represents the took of 10 iterations, and in the x-axis you can see those 10 iterations, and y-axis represents the accuracy and loss values. In this graph, the green line represents the accuracy and the blue line represents the loss. In this graph, we can see that each increasing epoch accuracy gets increases and the loss got decreases. And this accuracy reached to 100% and the loss reached to the 0%. In this way, we can give the accuracy and loss graph of apple disease, and close this graph. And click on upload test image and predict disease button to upload the test image and get this result. And to select any one of the test image from this test data, and I am selecting of a image and click on open button. Here the disease is predicted as scab. In this way, we can find the disease of in different type of apple images. And finally, the project proposes a deep learning based classification model for identification of diseased and healthy apple leaves. The convolution neural network is utilized for multi-class classification and prediction model. The proposed model provides an automated system for identification of apple diseases, which can be expanded to the other fruits and vegetables in the future too. The performance of the model is measured via accuracy with the help of performance metrics, and the result is analyzed with its future scope. The proposed model achieved an accuracy of the 99.03% in the classification of the apple diseases. The study concludes that proposed model can be used as an effective tool for the early detection of apple disease, which can help in reducing the economic loss in the agriculture industry.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.